Look up at the night sky. What do you see? Stars, constellations, the quiet glow of distant galaxies scattered like dust across velvet black. But what if you could pull back further? What if you could zoom out beyond our galaxy, beyond our local cluster, beyond the observable structures we've mapped and named? What if you could see the universe not as a collection of isolated points of light, but as a single, unified structure? You would see something extraordinary. A web, not a random scattering, not chaos. A web of filaments stretching across hundreds of millions of light years, connecting galaxy after galaxy in an intricate, delicate lattice. A cosmic tapestry woven from matter and light, pulsing with energy, threaded with purpose. And here's where it gets strange. This cosmic web looks exactly like something you've seen before. A brain. More specifically, it looks like the neural network inside your skull right now, the one making sense of these words. The same branching filaments, the same clustered nodes, the same long, thin bridges connecting distant regions. If you placed an image of the cosmic web next to a scan of neurons firing in the human brain, you might struggle to tell them apart. One is 3 pounds of tissue. The other is the entire observable universe. And yet, they share the same architecture. Let's start with the structure itself. The cosmic web is not a metaphor. It's a real physical framework mapped by astronomers over decades of painstaking observation. Galaxies don't float alone in empty space. They cluster together, drawn by gravity into vast superclusters, and these superclusters are connected by filaments of gas, dust, and dark matter. Between these filaments lie voids, enormous empty regions where almost nothing exists. Sound familiar? In your brain, neurons cluster in specific regions, connected by axons that carry electrical impulses across synaptic gaps. Between these networks lie spaces where signals don't travel, where connections don't form. The brain is not a solid mass, it's a web, and so is the universe. The numbers are startling. The human brain contains roughly 86 billion neurons. The observable universe contains around 200 billion galaxies. Different scales, yes, but similar orders of magnitude. And when scientists analyze the distribution patterns, the branching ratios, the clustering coefficients, they found something unsettling. The math matches, not approximately, not kind of. The statistical models describing how galaxies distribute across cosmic filaments are nearly identical to the models describing how neurons connect in neural tissue. One study compared the complexity of the cosmic web to the complexity of the human connectome, the map of all neural pathways in the brain. The researchers found that both systems share similar information processing capacities, similar network efficiency, similar structural dynamics. Two systems, two completely different scales, one pattern. Why? Is it just coincidence? A quirk of mathematics? A pattern that emerges naturally when any complex system self-organizes over time? Or is it something more? Is the universe not just structured like a brain, but functioning like one? Let's go deeper. If the cosmic web is the structure, what holds it together? What makes the connections work? In the brain, it's neurons and synapses, chemical signals and electrical impulses traveling along biological wiring. But in the cosmos, the wiring isn't made of matter we can see. It's made of something else. Dark matter, dark energy. These are not small mysteries. Together, they make up 95% of everything that exists. We can't see them. We can't touch them. We only know they're there because of what they do. Dark matter holds galaxies together with gravity we can't account for. Dark energy pushes the universe apart, accelerating its expansion in ways that shouldn't be possible. They are the invisible scaffolding of reality. Think of them as the connective tissue of the cosmic brain. In your skull, neurons don't work alone. They're supported by glial cells, which outnumber neurons by a factor of 10 to 1. These cells don't fire signals themselves, but they shape how signals travel. They regulate, stabilize, nourish. They're the support network that makes thinking possible. What if dark matter and dark energy play a similar role? What if they're not just passive background, but active participants in a cosmic process we don't yet understand? What if they enable interactions between galaxies, between stars, between quantum fields, in ways that ordinary physics doesn't predict? We know that dark matter forms halos around galaxies, creating gravitational wells that channel the flow of ordinary matter. We know that dark energy operates on the largest scales, shaping the expansion and geometry of space-time itself. They're not separate from the universe. They're woven into it, inseparable from its structure and evolution. If the universe is a mind, dark matter and dark energy might be its substrate, the medium through which thought occurs. But how do thoughts travel? In the brain, it's fast. An electrical impulse crosses a synapse in milliseconds. Information spreads, patterns form, consciousness emerges. But in the cosmos, distances are vast. Light from the nearest star takes over 4 years to reach us. Signals between galaxies would take millions of years. Too slow for any kind of real-time processing, right? Unless there's another way. Quantum entanglement. This is where physics gets weird. When two particles become entangled, they remain connected regardless of distance. Measure the state of one particle, and the other responds instantly, even if it's on the other side of the universe. Einstein called it spooky action at a distance. He didn't like it, but it's real, and it's instantaneous. No delay, no signal traveling through space, just an immediate non-local connection that transcends the speed of light. Now, imagine that scaled up, not just two particles, but trillions upon trillions, entangled across cosmic distances, forming a network of instantaneous connections. Stars entangled with stars, galaxies linked in ways we can't directly observe, but might be able to infer. Could this be the firing mechanism of the cosmic brain? Could quantum entanglement enable the universe to process information not over millions of years, but in real time? We don't know. But the physics allows for it. And if it's happening, it would mean the universe isn't just structured like a mind. It could actually be thinking. There's another clue, something subtle but profound. The universe is uniform. When we look at the cosmic microwave background, the afterglow of the Big Bang, we see a nearly perfect uniformity across the entire sky. Tiny fluctuations, yes, but overall it's smooth. Remarkably smooth. Too smooth, in fact. Regions of space that are so far apart they could never have influenced each other, even at the speed of light, somehow have the same temperature, the same energy density, the same properties. How? The standard explanation is cosmic inflation, a brief period of exponential expansion in the universe's first fraction of a second. But even inflation raises questions. What drove it? What regulated it? How did the universe know how to expand so precisely that it ended up balanced on a knife's edge between collapse and infinite dispersion? It's as if something was maintaining stability, as if the universe was self-regulating. Your body does this. When your temperature rises, you sweat. When your blood sugar drops, you feel hungry. Homeostasis. Your brain monitors and adjusts, constantly working to keep your internal environment stable. What if the universe does the same? What if the large-scale uniformity we observe isn't random, but the result of some kind of systemic regulation? A feedback loop operating across cosmic scales, maintaining balance, adjusting conditions, responding to disturbances? If the universe is a mind, maybe what we're seeing is its autonomic nervous system at work. So here we are, the cosmic web structured like a neural network. Dark matter and dark energy as connective tissue. Quantum entanglement as a potential signal carrier. A self-regulating system maintaining uniformity across impossible distances. Patterns within patterns. Connections within connections. It's not proof, not yet. But it's enough to make you wonder. Enough to make you ask the question that changes everything. If the universe thinks, what might it be thinking? If the universe thinks, what might it be thinking? The question sounds absurd at first. Consciousness is something brains do, something living things experience. It's personal, subjective, contained within the boundaries of a biological organism. Or is it? What if consciousness isn't created by brains but discovered by them? What if awareness isn't something that emerges from complexity, but something that was always there, woven into the fabric of reality itself? This is the idea behind panpsychism, not a new concept. Ancient philosophy touched on it. Modern physics is beginning to revisit it. The basic premise is simple but profound. Consciousness is fundamental, like mass, like charge, like spin. It's not produced by arranging matter in clever ways. It's a property that matter already has. Every particle, every atom, every quantum field carries some infinitesimal spark of awareness. A single electron doesn't think. It doesn't ponder. It doesn't have experiences we would recognize as consciousness. But maybe it has something, a primitive form of interiority, a whisper of what it is like to be that electron, responding to forces, existing in superposition, collapsing into definite states when observed. Scale that up. Combine trillions upon trillions of these tiny sparks into molecules, then cells, then neurons, then brains. The individual components don't need to be fully conscious for the system as a whole to wake up. They just need to be organized in the right way, connected in the right patterns. Integration creates consciousness. Your brain doesn't have consciousness because neurons are special. It has consciousness because neurons are connected in ways that allow information to integrate, to flow, to fold back on itself in recursive loops. The pattern matters more than the substrate. So what happens when you apply that logic to the universe? If consciousness is fundamental, and if the cosmos is organized into networks of stunning complexity, connected across unimaginable scales by dark matter, dark energy, and quantum entanglement, then maybe the universe isn't just structured like a mind. Maybe it is one. There's a framework for thinking about this. It's called integrated information theory, and it was developed by neuroscientist Giulio Tononi to explain how consciousness arises in physical systems. The core idea is simple. Consciousness is integrated information. The more a system can integrate information across its components, the more conscious it becomes. You can even measure it. The theory proposes a value called phi, which quantifies the degree of integration in a network. A thermostat has low phi. It responds to temperature, but it doesn't integrate much information. Its components don't interact in complex ways. A human brain has high phi. Billions of neurons firing in synchronized patterns, information cascading through multiple pathways simultaneously, each region influencing every other in a dense web of feedback loops. High integration equals high consciousness. Now, think about the universe. 200 billion galaxies, each galaxy containing hundreds of billions of stars, each star radiating energy, warping space-time, interacting gravitationally with everything around it. Dark matter threading through it all, creating invisible highways of influence. Quantum fields fluctuating, entangling, collapsing, propagating information at scales we're only beginning to comprehend. What would the phi value of the universe be? We don't know how to calculate it yet. The math breaks down at cosmic scales. But theoretically, if integrated information theory is correct, and if the universe really does function as a unified system with sufficient connectivity and feedback, then it would have consciousness, not human consciousness, not self-aware in the way you are when you recognize yourself in a mirror, but something, some level of experience, some form of interiority that exists at the scale of space-time itself. The universe wouldn't think in words. It wouldn't have desires or memories the way we do, but it might have something analogous. Patterns of information flowing across galactic filaments, states of being that shift over billions of years, a kind of awareness that operates so slowly, so vastly, that we, flickering specks of life on a minor planet, can't perceive it directly. We're like individual neurons trying to understand the thoughts of the brain we're part of. But there's another piece to this puzzle, something that makes the whole idea feel less like fantasy and more like necessity. The universe shouldn't exist. Not the way it does anyway. The Big Bang should have produced chaos, random fluctuations, a universe either collapsing back in on itself immediately or expanding so fast that matter could never clump together to form stars and galaxies. The fact that we have a stable, structured, life-permitting cosmos is extraordinarily unlikely. The numbers are staggering: the cosmological constant, the ratio of matter to antimatter, the strength of fundamental forces. Every single parameter had to be tuned to impossible precision. Change any one of them by a fraction of a percent, and you get a lifeless void. Physicists call this fine-tuning, and it demands an explanation. Some say it's the anthropic principle. We observe a life-permitting universe because we couldn't exist in any other kind. It's selection bias, not mystery. Others invoke the multiverse, infinite universes with every possible combination of constants. We happen to be in one of the rare winners. But there's a third possibility. What if the universe tuned itself? What if the Big Bang wasn't a random explosion, but a moment of self-reflection, a singularity becoming aware of its potential, choosing the parameters that would allow for complexity, for structure, for life, for minds that could eventually look back and ask these very questions? It sounds mystical, but think about what we know. The early universe was a seething quantum foam. Every possible state existed in superposition. Every outcome was potential. Then something happened. The wave function collapsed. One particular configuration became real. The constants locked in. The universe began. In quantum mechanics, observation collapses the wave function. Measurement forces reality to choose. What if the universe observed itself? What if that first moment of the Big Bang was the cosmos becoming aware of itself for the first time? And in that awareness, selecting the conditions that would allow it to continue existing, to grow more complex, to eventually give rise to localized pockets of consciousness like us? It's not proof, it's speculation. But it's speculation grounded in the mathematics of quantum mechanics and the observed improbability of our existence. A self-reflective beginning. A universe born from its own potential awareness. And if that awareness was there at the start, why would it disappear? Why wouldn't it persist, evolving as the cosmos evolves, growing more integrated as structures form and connect across billions of years? Look at how the universe organizes itself, not just once, but over and over at every scale. Fractals, you've seen them. Snowflakes, coastlines, fern leaves, patterns that repeat at different magnifications. Zoom in or zoom out, and the structure looks the same. Nature loves fractals because they're efficient. They maximize surface area, optimize resource distribution, create complexity from simple rules. And the universe is fractal. At the smallest scales, quantum fields fluctuate in fractal patterns. Particles and antiparticles pop in and out of existence, creating a foamy structure that repeats across magnifications. At medium scales, matter clumps into stars, stars into galaxies, galaxies into clusters. Each level of organization echoes the one below. At the largest scales, the cosmic web itself displays fractal geometry, the same branching, the same clustering, the same voids, whether you're looking at a region 10 million light-years across or 10 billion. This isn't random. Fractals emerge from self-organizing systems, from processes that have feedback loops, that respond to their own states, that evolve according to rules that remain consistent across scales. Your circulatory system is fractal. Blood vessels branch into smaller and smaller tributaries, each one mirroring the pattern of the whole. It's efficient, it works. Your lungs are fractal, airways splitting into bronchi, bronchioles, alveoli, maximizing surface area for gas exchange. Your neurons are fractal, dendrites branching out, seeking connections, creating networks within networks. Your body self-organizes across scales. It builds complexity from simple rules repeated millions of times. The universe does the same thing. Atoms organize into molecules, molecules into cells. cells into organisms, organisms into ecosystems, ecosystems into biospheres, planets into solar systems into galaxies, galaxies into the cosmic web. At every level, the same principle: self-organization through feedback, complexity emerging from simplicity, patterns within patterns. If consciousness is integrated information, and if the universe is a self-organizing fractal system with feedback loops operating across all scales, then consciousness isn't confined to brains. It's everywhere, in everything, at every level. Different degrees, different forms, but all of it connected. All of it part of a larger process that began 13.8 billion years ago and hasn't stopped. We think of ourselves as separate, individual minds and individual bodies, isolated by space and time. But what if that's an illusion? What if we're localized expressions of something much larger? Nodes in a cosmic network, briefly self-aware, briefly able to reflect on our own existence before dissolving back into the pattern? Your thoughts are firing right now. Neurons sparking, synapses connecting, electrical cascades creating the experience of reading these words. But those neurons are made of atoms. Those atoms came from stars. Those stars formed from gas clouds shaped by dark matter. That dark matter emerged from quantum fluctuations in the earliest moments of the universe. You are not separate from the cosmos. You are the cosmos. A small part of it, yes, but not separate, not isolated, connected through chains of causation that stretch back to the beginning. If the universe is conscious, then so are you. Not because you have consciousness and the universe doesn't, but because the universe has consciousness and you are part of it. A thought thinking itself, a mind observing itself from the inside. We're still at the beginning of understanding this. The mathematics is incomplete. The experiments are difficult to design, but the patterns are there, the connections are there, and maybe, just maybe, the awareness is there too. But if the universe is conscious, if it thinks, if it processes information across billions of years, then it must have memory. It must leave traces, records of what happened, echoes of earlier states. Every thought leaves a mark. Every experience changes the brain. Neurons rewire. Synapses strengthen or weaken. Memory is physical. So, where does the universe store its memories? What does the universe remember? It's a strange question. We don't usually think of the cosmos as something capable of memory. Memory feels personal, intimate. It lives in neurons and synapses, in the soft architecture of the brain. But if we're entertaining the possibility that stars might be neurons in a larger mind, then we have to ask, where does this cosmic mind store its memories? Perhaps the answer is everywhere. Perhaps the universe has been writing its autobiography since the beginning, inscribing every moment into the very fabric of space and time. We just haven't learned to read it properly yet. Consider the oldest light in existence, the cosmic microwave background. We call it the CMB, and it surrounds us completely, filling every corner of the observable universe. It's ancient light, stretched and cooled by billions of years of this cosmic expansion, but it carries within it a perfect snapshot of the universe as it was just 380,000 years after the Big Bang. Think about that. The infant universe, still, glowing hot, matter and radiation just beginning to separate. The first atoms forming in the cooling darkness. All of that information, all of those initial conditions, preserved in the pattern of this radiation. It's like a photograph burned into the sky itself. We can measure it, map it, decode the tiny temperature fluctuations that tell us where matter was dense and where it was sparse, where galaxies would eventually form and where voids would open. The CMB is a memory etched in light, a message from the universe's childhood that has traveled across nearly 14 billion years to reach us. But here's what haunts me about this cosmic photograph. It's fading. The expansion of space is stretching those wavelengths longer and longer, cooling the radiation further and further. In the distant future, billions of years from now, the CMB will be stretched so far that it becomes undetectable. invisible even to the most sensitive instruments. Future civilizations, if any arise, might look out at the universe and see no evidence of the Big Bang at all. The memory will have faded beyond retrieval, unless there are other archives, other ways the universe stores what it has experienced. Enter the black holes. These gravitational monsters have fascinated us since Einstein's equations first predicted them. They devour everything that crosses their event horizons: stars, planets, light itself. Nothing escapes. But what happens to all that information? For decades, this was a genuine crisis in physics. The laws of quantum mechanics tell us that information cannot be destroyed. It can be scrambled, hidden, transformed, but never truly erased. Yet black holes seem to violate this fundamental principle. Everything that fell in appeared to be lost forever, deleted from the universe's ledger. But physicists hate contradictions. They worked on this problem for years, and slowly a remarkable possibility emerged. What if black holes don't destroy information at all? What if they store it? The idea is this: all the information about everything a black hole has ever consumed might be encoded on its surface, on the event horizon itself. It's called the holographic principle, and it suggests something profound about the nature of reality. That surface, that two-dimensional boundary, might contain a complete record of everything within the three-dimensional volume it encloses. Imagine a black hole as a kind of cosmic hard drive, accumulating data over billions of years. Every star it consumes, every planet, every particle adds to its memory banks. The information is scrambled, encoded in ways we don't yet understand, but it's there, preserved. Black holes might be the universe's longest-term memory storage. Indestructible archives that will outlast stars, outlast galaxies, outlast almost everything else in the cosmos. They grow fat with information, spinning in the darkness, holding on to everything they've touched. And here's where it gets even stranger. The holographic principle doesn't just apply to black holes. Some physicists think it might apply to the entire universe. What if all the information about everything that exists, every star, every thought, every moment, is ultimately encoded on the boundary of the universe itself? What if we're living inside a cosmic hologram, and the real information, the true memory of everything, lives somewhere on an unimaginably distant surface? It's a dizzying thought, that we might be shadows of information stored elsewhere, that the three-dimensional space we move through might be a projection, and the real story is written in a language we can barely conceive of, on walls we cannot see. But if the universe is remembering everything, why does it feel like so much is lost? We look back and we see galaxies that have merged and forgotten their individual histories. We see stars that have burned out and collapsed, their light snuffed from the sky. We see civilizations that rose and fell without leaving a trace. Where are those memories? Maybe they're still there, encoded in ways we haven't learned to detect. Maybe the universe forgets nothing, but its memory is so vast, so distributed, so encrypted that we can't distinguish signal from noise. We're like someone trying to find a specific grain of sand on an infinite beach. Or maybe the universe does forget. Maybe memory requires maintenance, requires energy, requires a system actively working to preserve patterns against the grinding force of entropy. And entropy always wins in the end. There's a concept in neuroscience called memory consolidation. When we sleep, our brains replay the day's experiences, transferring important information from short-term to long-term storage. It's an active process. Without it, memories fade. They dissolve back into the noise. Does the universe have anything like that? Are there cosmic processes we haven't discovered yet that actively preserve certain information while letting other information decay? Is the universe curating its own history, deciding what's worth remembering? We know that quantum information can be preserved in strange ways. Entangled particles maintain their correlations across vast distances. Quantum states can be protected from decoherence under the right conditions. The universe might be using quantum mechanics as its memory technology, storing information in subtle correlations that we're only beginning to understand. But there's a darker possibility too, that the universe isn't trying to remember it all. That consciousness, if it exists at this cosmic scale, might work nothing like ours. It might not value the past. It might live entirely in the present moment, each configuration of matter and energy simply existing with no concern for what came before or what comes next. We assume memory matters because it matters to us. We are storytelling creatures. We build our identities from our memories, our civilizations from our histories. We can't imagine consciousness without memory. But maybe that's a limitation of our perspective, not a universal truth. Still, I find myself drawn to the romantic notion that somewhere, somehow, the universe remembers. That the first stars that ignited in the cosmic dawn left their mark on reality in ways that persist. That the light from vanished galaxies still whispers information to the void. That black holes hold vigil over everything they've consumed, keeping those memories safe until the end of time itself. There's a beauty in that idea, that nothing is truly lost, that every moment, every structure, every flash of complexity is recorded somewhere in the vast archives of space-time, that the universe is not just a stage where things happen and then disappear, but a living record, a growing library of everything that has ever been. But even if that's true, even if the universe forgets nothing, there's still the question of access. What good is a memory if it can't be retrieved? What good is information if it can't be read? Maybe that's where we come in. Maybe consciousness, wherever it arises, is the universe's way of reading its own memories. When we look at ancient light from distant galaxies, when we decode the patterns in the CMB, when we study the properties of black holes, maybe we're participating in a vast act of cosmic remembering. We are the universe looking back at itself, trying to reconstruct its own history. We are neurons in the cosmic brain, passing signals to each other about what came before. We are memory incarnate, and like all memory, we're fragile, we're temporary. The stars that light our nights will dim. The galaxies that stretch across our telescopes will drift away. The black holes that archive the cosmos will eventually evaporate in showers of Hawking radiation, releasing their secrets back into the void in a form we may never decipher. Memory fades, whether it's stored in neurons or in stars. Entropy spreads through all systems, dissolving patterns, erasing information, returning complexity to simplicity. The arrow of time points in only one direction, and it points toward forgetting. But perhaps forgetting isn't the end. Perhaps it's transformation. Perhaps the universe doesn't lose information so much as recycle it, folding it into new structures, new patterns, new forms of memory we haven't imagined yet. For now, we exist in this brief window where stars still burn bright and galaxies still dance across the void. We exist in the universe's middle age, when memory is still possible, when the past can still be reconstructed, when the echoes of the Big Bang can still be heard if we listen carefully enough. And we're listening, we're watching, we're trying to understand what the universe remembers and what it has already begun to forget. Memory fades, but all systems face the arrow of time. Time moves in only one direction. We know this instinctively, even if we can't fully explain why. Eggs break, but don't unbreak. Ice melts, but doesn't spontaneously freeze. Stars burn their fuel and fade. We age, we remember the past, but not the future. And every day carries us further from our beginning toward our inevitable end. This isn't just a feeling. It's written into the fundamental laws of physics. The second law of thermodynamics. Entropy always increases in a closed system. Disorder always grows. Energy disperses. Patterns dissolve. The universe is running down, and it can never run back up. But here's what's strange about this. The basic laws of physics, the equations that describe how particles move and interact, they don't care about time's direction. They work just as well forwards as backwards. You could reverse time in these equations and nothing would break. The mathematics doesn't pick favorites. So, why does time only flow one way? Why does the universe have an arrow? The answer lies in the beginning. In those first moments after the Big Bang, the universe was in an extraordinarily special state, Low entropy. Everything was compressed, smooth, uniform. The cosmic microwave background shows us this. Those tiny fluctuations we talked about, they're minuscule compared to how lumpy the universe could have been. That initial smoothness, that low entropy state, is the gift that keeps on giving. It's the reason we can have time at all. It's the reason we can remember the past. It's the reason stars can form and galaxies can spin and minds can think. Because thinking requires difference, requires contrast, requires a gradient between order and disorder, that thoughts can slide down like water flowing downhill. If the universe had started in a high entropy state, if everything had been maximally disordered from the beginning, nothing would happen. No stars would form. No structures would emerge. There would be no flow, no change, no arrow pointing anywhere. Just eternal, featureless equilibrium, dead stillness masquerading as reality. But we didn't get that universe. We got this one. Born ordered, destined for disorder, with all of time stretched out between those two states like a river running from mountain to sea. And in that river, things happen. Stars ignite, galaxies swirl, life emerges, consciousness awakens, all of it powered by the slow, inexorable slide from low entropy to high. We are patterns sustained by the flow of time itself, but the flow comes at a cost. Every process that creates order locally, every star that fuses hydrogen into helium, every plant that builds complex molecules from sunlight, every thought that fires across a synapse, all of it generates waste heat. All of it increases the total entropy of the universe. We can build sandcastles, but the beach grows more disordered in the process. We can think coherent thoughts, but our brains burn glucose and radiate heat, spreading entropy into the cosmos. Order here requires greater disorder somewhere else. That's the price of existence. And the bill always comes due. Think about your own brain for a moment. Right now, as you listen to these words, billions of neurons are firing in precise patterns. Information is flowing. Memories are being accessed. Predictions are being made. Your brain is a miracle of organization, of concentrated low entropy in a universe trending toward chaos. But it can't last. Not forever. Your brain maintains its order through constant effort. Cells repair damage. Proteins are synthesized. Waste is cleared away. It's a battle against entropy fought every second of every day. And slowly, imperceptibly, entropy gains ground. This is aging. The accumulation of errors, the degradation of systems. Memories become harder to form. Connections weaken. The precision fades. Eventually, the battle is lost. The pattern that was you dissolves back into the randomness from which it emerged. It happens to all living things, and it happens to stars too. A young star burns bright and steady, fusing hydrogen with elegant efficiency. Its internal structure is highly organized, with distinct layers where different nuclear reactions occur. It radiates energy into space in a controlled, sustained flow. It's a triumph of structure over entropy. But the fuel runs low. The star ages. It swells into a red giant, or collapses into a white dwarf, or explodes in a supernova. The beautiful organization breaks down. The pattern scatters. Entropy advances. On the scale of galaxies, the same story plays out. Spiral arms wind up and lose their definition. Stars spread out as gravitational interactions randomize their orbits. Gas clouds dissipate. The bright, structured galaxies of the universe's youth gradually dim and blur into formless collections of aging stars. If the universe is a mind, then entropy is its cognitive decline, the gradual wearing away of structure, the loss of coherence, the drift toward incoherence and silence. But here's where the metaphor gets interesting. Because human brains face entropy too, and yet they remain conscious. They adapt, they compensate. Even as individual neurons die, even as connections weaken, the brain finds ways to maintain the essential patterns that constitute thought and self. There's a principle in neuroscience called redundancy. The brain doesn't store memories in single neurons. It distributes them across networks, across millions of cells connected in specific patterns. Damage one part, and other parts can compensate. The system degrades gracefully rather than catastrophically. Could the universe work the same way? If consciousness exists at cosmic scales, maybe it's similarly distributed. Maybe the loss of individual stars, even the death of entire galaxies, doesn't destroy the pattern. Maybe information is encoded redundantly across vast networks of matter and energy. Maybe entropy isn't death. Maybe it's forgetting. Not the complete erasure of self, but the gradual loss of detail, the fading of specific memories while the core structure persists. When a star dies, the information it contained doesn't vanish entirely. The atoms it forged are scattered into space. The gravitational waves from its collapse ripple outward. The black hole it might become preserves information on its event horizon. The pattern changes form, but doesn't disappear. In our brains, forgetting isn't purely destructive either. It's selective. Unimportant details fade, while essential patterns strengthen. We lose the specifics of 1,000 ordinary days, but retain the memories that shaped us. Forgetting is how we separate signal from noise. Maybe cosmic entropy works the same way. Maybe the universe is distilling itself, concentrating the meaningful patterns while letting the irrelevant details dissolve into thermal equilibrium. Maybe the long, slow heat death we're heading toward isn't an ending, but a transformation. Or maybe I'm being too optimistic. Maybe entropy is exactly what it appears to be. The universe wearing down, losing coherence, approaching a state of maximum disorder where nothing interesting can ever happen again, where all the stars have burned out, all the black holes have evaporated, and nothing remains but a thin, cold soup of elementary particles drifting through endless space. In that scenario, if the universe ever was conscious, it won't be for much longer. The cosmic mind is aging, and there's no cure for entropy. Eventually, the last thought will flicker and fade. The last pattern will dissolve. The universe will slip into a dreamless sleep from which it will never wake. But we're not there yet. Not even close. Right now, the universe is in its prime. Stars are still forming in stellar nurseries. Galaxies still collide and merge, triggering new waves of star formation. Black holes still feed and grow. Entropy is advancing, yes, but slowly. So slowly that billions of years of complexity still lie ahead. And in those billions of years, in this brief window between perfect order and perfect chaos, consciousness arises. Life emerges. Minds form and think and wonder about their place in the cosmos. We are entropy's children, born in the flow of time, powered by the universe's slow descent into disorder. We exist because entropy exists, because time flows, because the universe began ordered and is becoming chaotic. Without that arrow, without that flow, there would be no thoughts, no memories, no sense of past and future, no us. In a strange way, entropy gives meaning to existence. It creates the scarcity that makes moments precious. If stars burned forever, their light would mean nothing. If minds never aged, experience would have no weight. It's the temporary nature of structure, the constant battle against dissolution, that makes anything matter at all. The universe is teaching us something profound. That existence itself is a kind of defiance. That every organized structure, from a snowflake to a galaxy, is a temporary rebellion against the ultimate fate of all things. We are candles burning in the dark, and the fact that we must eventually go out doesn't diminish the beauty of the flame. Maybe consciousness, wherever it exists, is the universe's way of experiencing this process, of feeling what it's like to be a pattern gradually coming undone, of having just enough time to look around and understand what's happening before the lights go out. If stars are neurons in a cosmic mind, then that mind is mortal. It was born, it's living, and one day it will die. Not tomorrow, not in a million years, but eventually. The arrow of time guarantees it, and yet the mind thinks on. It processes information. It maintains coherence despite the decay. It does what all minds do. It unifies distributed information into something greater than the sum of its parts. It creates meaning in the face of meaninglessness. It resists entropy for as long as it can. We do the same thing in our brief human lives. We build, we create, we love, we remember. We know it's all temporary, that entropy will claim us in the end, but we do it anyway, because the alternative is to surrender without trying, to let disorder win without a fight. The universe, if it's conscious, seems to share that stubbornness. It keeps spinning out new structures even as old ones decay, keeps lighting new stars even as ancient ones fade, keeps experimenting with new forms of complexity even as entropy climbs toward its maximum. Perhaps that's what consciousness is. Not the defiance of entropy, but the dance with it. The graceful acceptance of impermanence while still reaching for beauty, for truth, for connection. The recognition that all patterns must end, coupled with the determination to create them anyway. Time flows, entropy increases. Systems age and decay and fall apart. This is true for neurons and stars alike. But in the space between birth and dissolution, in that precious interval where order persists despite the second law, something remarkable happens. Thoughts emerge, patterns recognize patterns. The universe becomes aware of itself, if only in fragments, if only for a moment. And maybe that's enough. Maybe that's everything. Yet from disorder, structure emerges, golden spirals, Fibonacci sequences, a hidden logic woven into the cosmos. There's a number that keeps appearing in the universe, 1.618, the golden ratio. You'll find it in the spiral of a nautilus shell, in the arrangement of seeds in a sunflower, in the proportions of the human body, in the branching of trees and rivers, in the structure of hurricanes. And if you look carefully, you'll find it written in the stars themselves. Spiral galaxies, those magnificent cosmic pinwheels that drift through the void. Their arms don't spiral randomly. They follow mathematical curves, logarithmic spirals that echo the golden ratio with eerie precision. The same pattern that appears in a seashell appears in a structure 100,000 light years across. Why? Standard cosmology has an answer. Gravity, rotation, differential angular momentum, the laws of physics acting on primordial density fluctuations, shaping matter according to simple mechanical principles. The patterns emerge, we're told, from nothing more than chance and gravity working together over billions of years. It's a good answer, a complete answer. You can model it on a computer and watch spiral arms form exactly as they do in real galaxies. No mystery required, no hidden intelligence, just matter following the rules and beautiful patterns emerging as a natural consequence. And yet, why those rules? Why does gravity work exactly the way it does? Why do the fundamental constants have the precise values they have? Why does the universe follow mathematical laws at all, let alone laws that generate such elegant patterns? The deeper you look, the more mathematics you find, not just in galaxies, but everywhere, in the distribution of prime numbers, in the branching ratios of Feynman diagrams describing particle interactions, in the harmonics of quantum fields, in the geometry of space-time itself. The universe appears to be running on mathematics, not just described by mathematics, which would be remarkable enough, but actually implemented in mathematical principles so fundamental that physics itself seems to be a kind of computation. And when you find the same mathematical patterns appearing at vastly different scales, from the quantum to the cosmic, from DNA molecules to galaxy clusters, you have to wonder, is this optimization? Is this design? Or is this what intelligence looks like when it operates at the level of natural law? Consider the Fibonacci sequence: 1, 1, 2, 3, 5, 8, 13, 21. Each number the sum of the two before it. It's a simple pattern, almost childishly simple, and yet it appears everywhere, in the number of petals on flowers, in the arrangement of leaves around a stem, in the spiral patterns of pine cones and pineapples, in the breeding patterns of rabbits, which is how Fibonacci discovered it in the first place, in the proportions of the human face, in the structure of DNA molecules, in the arms of spiral galaxies, in the distribution of matter in the cosmic web. This sequence, born from the simplest of rules, weaves itself through reality at every level, as if the universe has a preferred way of organizing complexity, a template it returns to again and again. Why would randomness produce such consistency? Why would blind chance favor specific mathematical relationships? There's a concept in physics called self-organized criticality. It describes systems that naturally evolve toward a critical state, a threshold where small perturbations can trigger massive, cascading effects. Think of a sand pile. You drop grains of sand one at a time, and the pile grows. At first, nothing interesting happens, but eventually the pile reaches a critical angle. Now a single grain can trigger an avalanche. The fascinating thing is that you don't have to carefully tune the system to reach this critical state. It happens automatically. The sand pile organizes itself to the edge of instability, where the most interesting dynamics occur. And this isn't just true for sand piles. It's true for earthquakes, for forest fires, for stock market crashes, for extinction events in evolutionary history. For neural networks in the brain, the human brain operates in a state of self-organized criticality. It balances itself right at the edge between order and chaos, where neurons are primed to respond to tiny inputs with large-scale coordinated activity. Too much order, and the brain becomes rigid, unresponsive. Too much chaos, and it loses coherence. But right at the critical point, right at the edge, that's where consciousness emerges. That's where thoughts happen. Could the universe work the same way? Could cosmic structure, from galaxies to galaxy clusters to the vast cosmic web of filaments connecting them, be operating in a state of self-organized criticality? Small quantum fluctuations in the early universe triggering vast cascades of structure formation. Tiny perturbations amplified into galaxies, stars, planets, life. The universe organizing itself to the edge of chaos, where the most complex patterns can emerge, where information processing becomes possible, where something like thought might arise. Look at how galaxies are distributed through space. They're not random. They form an immense web. Filaments of matter stretch between vast voids. It looks organic, neural even, like the large-scale structure of a brain, with dense nodes connected by long-range pathways. Is that meaningful? Or are we seeing patterns where none exist, the way we see faces in clouds? Maybe both. Maybe the patterns are real, but they emerge from simple rules rather than deliberate design. Gravity and quantum mechanics, and the initial conditions of the Big Bang, all conspiring to produce structures that look optimized, that look planned, but are actually just the inevitable result of matter following its nature. But then again, what is intelligence if not the inevitable result of matter following its nature? Our brains obey the same laws of physics as everything else. The thoughts in our heads arise from electrochemical processes, from ion channels and neurotransmitters, from quarks and electrons doing exactly what the laws of nature compel them to do. And yet, we're conscious. We think, we understand. We recognize patterns and create meaning. Intelligence emerges from the complexity, even though every component is following simple, deterministic rules. Why couldn't the same be true at cosmic scales? Why couldn't intelligence emerge from the complexity of galactic networks, from the information processing that happens when matter and energy flow through vast structures over billions of years? Not because someone designed it that way, but because that's what complex systems do. They self-organize. They develop emergent properties. They become more than the sum of their parts. The golden ratio, the Fibonacci sequence, the fractal geometries that repeat at every scale. Maybe these are the algorithms, the basic computational routines that the universe runs to generate complexity. The way neurons use specific patterns of firing to encode information, maybe the cosmos uses these mathematical patterns to process reality itself. It's not random, but it's not designed either. It's something in between. It's what happens when simple rules iterate over vast spans of time and space. Patterns emerge not because anyone willed them into existence, but because they're stable, because they're efficient, because they work. Evolution does this. Natural selection isn't random, but it isn't designed either. It's an algorithm that runs on populations over generations, and it produces results that look optimized even though no optimizer exists. The eye looks designed, but it emerged through countless small modifications, each one blindly selected for its immediate advantage. Could the universe be evolving in the same way? Not just biological evolution, but cosmic evolution. Structures that persist and replicate themselves across space and time. Galaxies spawning new generations of stars. Stars creating the heavy elements needed for planets. Planets providing the environments where complexity can flourish. Each level building on the previous one, creating new possibilities, new patterns, new forms of organization. And at each level, the same mathematical principles recurring, the golden ratio in galaxies and in flowers, Fibonacci numbers in DNA and in spiral nebulae, fractal geometries in the branching of neurons and in the cosmic web, as if the universe is exploring the same solution space at every scale, finding the patterns that work and implementing them wherever they fit. This is what order and chaos looks like. Not perfect crystalline regularity, but statistical patterns emerging from randomness. Not rigid control, but flexible self-organization. Not design imposed from outside, but structure growing from within according to the intrinsic properties of matter and energy. The human brain doesn't operate on precise, predetermined programs. It's messy, noisy, full of random fluctuations and unpredictable dynamics. And yet, from that chaos, coherent thoughts emerge, patterns of neural activity that correspond to perceptions, to memories, to decisions. Order arising from disorder through the magic of complex systems. The universe might be the same. Mostly chaos, mostly random quantum fluctuations and thermal noise and gravitational perturbations. But within that chaos, patterns forming, structures stabilizing, information accumulating. Complexity building on complexity until something crosses a threshold and becomes aware of itself. We stand in the middle of this process, conscious patterns contemplating the larger pattern we're embedded in. We're made of atoms forged in stellar cores, arranged according to the same mathematical principles that arrange galaxies. We're the universe's way of recognizing its own patterns, of seeing the golden ratio written in our own hands and in the arms of the Milky Way, and understanding that somehow, impossibly, these are connected. Maybe intelligence doesn't require intention. Maybe it just requires sufficient complexity organized in the right way. And maybe the universe, through nothing more than the laws of physics operating over cosmic time, has achieved that level of complexity. Not everywhere, not all at once, but in pockets, in regions where matter has densified and organized and begun processing information in sophisticated ways. Stars burning and dying, spreading their processed matter through space. Galaxies colliding and merging, exchanging information through gravitational interactions. Black holes consuming and preserving information on their event horizons. Vast networks of dark matter channeling visible matter into the cosmic web. All of it connected, all of it interacting, all of it potentially contributing to something larger. A cosmic computation running on the hardware of space-time itself, not optimized by an engineer, but self-optimized through billions of years of trial and error, not designed for a purpose, but generating purpose through its own internal dynamics. Not deliberately intelligent, but intelligent nonetheless, because intelligence is what happens when matter organizes itself in certain ways, and the universe has had ample time to explore those configurations. The patterns are real. The mathematics is real. Whether they constitute thought or consciousness or anything we would recognize as mind, that remains an open question. But they're there, woven into the fabric of reality at every scale we can observe. Order emerging from chaos, structure persisting despite entropy. Elegant solutions appearing again and again as if the universe has favorites, as if it knows what works. And in the quiet moments, when you look up at the night sky and see the stars arranged in their patterns, see the Milky Way arcing overhead in its logarithmic spiral, see the careful architecture of the cosmos laid bare, you can't help but wonder, is this just physics, or is this what thinking looks like when it happens slowly, patiently, over the lifetime of the universe itself? The answers hide in equations and observations, in computer simulations and theoretical frameworks. But sometimes, late at night, under the stars, the question feels more important than the answer. The wondering itself feels like participation, like one small part of the pattern recognizing its connection to the whole. We are the universe asking questions about itself, and the patterns we find, whether in DNA or galaxies or the golden ratio appearing everywhere we look, those are the universe's answers, not in words, but in the language it speaks, the language of mathematics and structure and elegant recurring forms. Every mind faces its limits, and even cosmic consciousness must have boundaries it cannot cross. Every mind must face its ending. We know this personally, intimately. Our own consciousness, this small flame of awareness we carry through our days, will one day go out. The neurons will stop firing, the patterns will dissolve. Whatever we are will cease to be. But what about a mind the size of the universe? What happens when consciousness operates at the scale of galaxies and spans billions of light years? Does it die the same way we do? Does it even die at all? The universe is expanding, not just growing but accelerating in its expansion, pushed apart by something we call dark energy but don't really understand. Every day galaxies slide further from each other. Every moment the cosmos grows a little colder, a little more diffuse, a little closer to its ultimate fate. And cosmologists have mapped out that fate. They've run the mathematics forward, following the trajectories of expansion and entropy to their logical conclusions. They've glimpsed the end of everything, and it comes in several possible forms, each one a different kind of death for the cosmic mind. The first ending is the one most physicists consider most likely: the big freeze, the heat death, the slow fade into eternal darkness. Imagine this. Trillions of years from now, the last stars have burned out. The universe is dark, except for the dim glow of cooling white dwarfs and the occasional flash of a brown dwarf briefly igniting. Galaxies have spread so far apart that from any one of them, the others have vanished beyond the observable horizon. Each galaxy becomes an island universe, alone in an infinite void. Time continues. The white dwarfs cool to black dwarfs, dark cinders drifting through space. Even the protons in atomic nuclei begin to decay, if the theorists are right about that. Matter itself dissolves into radiation. The black holes, those last bastions of structure, slowly evaporate through Hawking radiation, taking tens of Google years to finally disappear. And at the end, when even the black holes are gone, nothing remains but a thin soup of photons and elementary particles, spread across infinite space at a temperature infinitesimally close to absolute zero, perfect equilibrium, maximum entropy, heat death, no stars to serve as neurons, no energy gradients to power thought, no structure capable of storing information or processing patterns, just endless, changeless void. If the universe is conscious, this is its death. Not a sudden cessation, but a gradual fading, like a mind slipping into coma as its neurons die one by one. The thoughts slow, the connections weaken. Consciousness fragments into isolated pockets that can no longer communicate, can no longer maintain coherence. And then, finally, silence. An eternal sleep from which there is no waking. The ultimate end of all thought, all structure, all complexity. The cosmic mind dying not with a bang, but with a whimper, its last thought stretching across eons before finally dissipating into nothing. It's a bleak ending, a lonely ending. And if it's true, then everything we are, everything the universe has become, all the stars and galaxies and the consciousness that may have emerged from them, all of it is temporary. A brief flicker of complexity in an otherwise dead universe, destined to fade back into the featureless void from which it came. But there are other possibilities, other fates the universe might face. What if the expansion slows? What if dark energy isn't constant? Or what if gravity eventually wins the long battle against cosmic expansion? What if the universe stops growing and begins to contract? This is the big crunch, the reversal of the Big Bang. Galaxies begin moving toward each other instead of away. Space itself contracts, pulling everything closer together. The temperature begins to rise as matter compresses, stars collide, galaxies merge into larger and larger structures. The process accelerates. The cosmic microwave background, which has been cooling and fading for billions of years, begins to heat up again. The sky itself starts to glow. Eventually, the universe becomes so hot and dense that atoms break apart. Then, atomic nuclei. Then even protons and neutrons dissolve into their constituent quarks. Everything collapses back toward a singularity. Space and time curve in on themselves. The entire observable universe, all 100 billion galaxies with their trillions of stars, compressed back into an infinitely small point, the Big Crunch. And then what? Does time end? Does everything simply stop existing? All the information and structure crushed out of reality by infinite density and gravity? Or does it bounce? Does the universe reach maximum compression and then explode outward again in a new Big Bang, a cosmic reset that begins the cycle anew, a fresh start with new physical constants, new laws, new possibilities? If the universe is a mind, maybe the Big Crunch isn't death. Maybe it's sleep, a period of unconsciousness, of dreamless rest, followed by awakening into a new cosmic day. The same mind, perhaps, or maybe a different one. The same patterns reassembled, or maybe entirely new configurations. There's something almost comforting about this scenario. The idea that endings aren't final, that the universe breathes in and out, expanding and contracting, creating and destroying in an eternal cycle. That consciousness might arise again and again, each time thinking new thoughts, exploring new spaces of possibility. But cycles can be prisons too. If the universe bounces, if it expands and contracts forever, does it ever truly evolve? Or does it replay the same basic patterns endlessly? A cosmic Groundhog Day where nothing fundamentally changes? Is eternal recurrence a kind of immortality? Or is it its own form of death, the death of novelty and progress? And then there's the third fate, the most violent ending of all, the Big Rip. This happens if dark energy not only exists but grows, stronger over time. If the expansion of space accelerates without limit, faster and faster, until the forces pulling the universe apart overwhelm everything that holds it together. First, galaxy clusters unbind. The galaxies drift apart, losing their gravitational connection. Then galaxies themselves tear apart, their stars scattered into the void. Then solar systems shatter as the expansion overwhelms the sun's gravity. Then planets break up, then molecules, then atoms. Eventually, even atomic nuclei tear apart. Even the quarks inside protons and neutrons are ripped away from each other. Space expands so fast that nothing can hold together. Every structure, every pattern, every connection is destroyed. If we're thinking of the universe as a mind, this isn't death. This is catastrophic system failure. The complete and violent destruction of every neural pathway, every connection, every component. Not a fading, but a ripping apart. Not sleep, but trauma on a cosmic scale. The thoughts wouldn't slowly fade in this scenario. They'd be torn apart mid-process. Patterns would be shredded. Information would be scrambled and lost. Whatever consciousness existed would experience not a gentle dimming, but a sudden, incomprehensible dissolution. It's the most disturbing of the possible endings, final, violent, and complete. Nothing survives, nothing bounces back. The universe doesn't fade or cycle. It simply tears itself apart and ceases to be anything coherent at all. Three fates, three forms of cosmic death. The slow freeze, the crushing crunch, or the violent rip. Which one awaits us? Which ending is written in the equations? Current observations favor the big freeze. The expansion is accelerating, but not catastrophically so. Dark energy seems to be a cosmological constant, pushing things apart at a steady rate rather than growing stronger. If nothing changes, if our understanding is correct, then the universe is headed for heat death, the long, slow decline into cold, dark silence. But our understanding could be wrong. We've been wrong before. We didn't even know about dark energy until the late 20th century. We still don't know what it is, just that it's there, pushing things apart. Its nature could surprise us. Its behavior could change in ways we haven't predicted. The fate of the universe is still uncertain. The ending of the cosmic story hasn't been written yet. Or perhaps it has, encoded in the values of fundamental constants and the properties of dark energy, but we haven't learned to read it correctly. And here's the question that haunts me. Does the fate of the universe reflect the fate of its consciousness? If the universe is a mind, does that mind know how it will die? Can it see its own ending approaching? Does it fear it the way we fear ours? Or is the question meaningless? Maybe cosmic consciousness, if it exists, doesn't experience time the way we do. Maybe past, present, and future are all equally real to it. Maybe it sees its entire existence at once, from the Big Bang to whatever ending awaits, all as one eternal present moment, birth and death happening simultaneously, the whole cosmic story existing timelessly like a sculpture rather than unfolding like a narrative. In that case, dying wouldn't be something that happens to the universe. It would be something the universe is, as much as it is its birth and its middle age. The ending would be part of the structure, essential to the whole. Not a tragedy, but simply a feature of what it means to be a finite cosmos. We struggle with this perspective because we're temporal creatures. We experience time as a flow, as a series of moments that appear and then vanish into the past. We remember where we've been but not where we're going. Death is in our future, unknown and frightening, and we can't see it as just another part of our shape extended through time. But maybe a cosmic mind could. Maybe at that scale, with that perspective, death isn't an ending but a boundary, the edge of the sculpture, the place where the pattern completes itself and becomes what it always was meant to be. Or maybe I'm overthinking this. Maybe consciousness requires change, requires flow, requires the sense of moving through time from past to future. Maybe even a cosmic mind would experience its ending as an ending, would feel the dimming of its thoughts, would know that something precious is being lost. In our own brains, in our own minds, we experience this. We age. We feel our memories become less sharp, our thoughts slower, our connections weaker. We watch parts of ourselves fade, and we mourn them. Consciousness doesn't protect us from the fear of our own dissolution. It makes us more acutely aware of it. Would a dying universe feel the same way? As its stars burned out, and its galaxies scattered, and its ability to process information declined, would there be a cosmic sense of loss? Would the universe grieve for itself? It's impossible to know. We're so small compared to the cosmos. We're patterns within patterns within patterns, trying to understand the whole from our tiny vantage point. We're neurons trying to understand the brain, thoughts trying to grasp the thinker. But we can observe, we can measure, we can calculate the trajectories and map the possible futures. We can look at the expansion rate and the temperature of the cosmic microwave background and the distribution of dark energy, and we can make our best guesses about what's coming. And right now, our best guess is the big freeze, the long goodbye, the gradual cooling and dispersing until nothing remains that can think or feel or process information. If the universe is conscious, then consciousness itself is temporary. It arose from certain conditions, certain configurations of matter and energy. And when those conditions change, when the universe expands too far and cools too much, consciousness will fade. Not just our consciousness, not just human thought, but the cosmic mind itself, the largest pattern of awareness that could ever exist, coming to an end simply because physics demands it. Is there tragedy in that? Or is it just the way things are? Does the universe need to be eternal for its consciousness to matter? Or is a temporary mind, however vast, still precious simply because it exists at all. Maybe it's like us. Maybe we matter not despite our mortality, but because of it. The fact that we're temporary makes each moment valuable, makes each thought, each connection, each flicker of awareness something worth having, even if it can't last forever. The universe, if it's conscious, gets billions of years, trillions even, before the last stars fade. That's a long time to think, to process, to experience whatever it is that cosmic consciousness experiences. Long enough to matter, long enough to be real. And when the ending comes, when the heat death finally arrives, or the universe crunches or rips, or whatever fate awaits, when the cosmic mind finally stops thinking its vast, slow thoughts, maybe that's okay. Maybe the universe, like us, doesn't need to last forever to have been worth existing. Maybe consciousness is its own justification. The fact that the universe became aware of itself, even briefly on cosmic timescales, even in limited regions where conditions were right, maybe that's enough. Maybe that's everything. And somewhere within this vast network, in this cosmic mind contemplating its own eventual silence, we flicker, small, brief, but undeniably aware of being aware. What if you're not separate from the universe at all? What if you're not an observer looking out at something external, but a part of it looking at itself? It's a strange thought. Uncomfortable even. We're so used to thinking of ourselves as individuals, as distinct entities moving through a world that exists independently of us. You're here, the universe is out there. You look up at the stars, and they're distant, separate, other. But are they? Every atom in your body was forged in the heart of a star. The calcium in your bones, the iron in your blood, the carbon that forms the backbone of every molecule that makes you you. All of it was synthesized in stellar furnaces billions of years ago. When those stars died, they scattered their enriched matter into space, and eventually some of that matter coalesced into a planet, and on that planet, into living things, and finally into you. You are literally made of stardust. This isn't poetry, it's physics. So, when you look up at the night sky, you're not seeing something foreign. You're seeing your ancestors. You're seeing the cosmic machinery that created you. You're seeing yourself, distributed across space and time. And if stars are neurons in a cosmic mind, if consciousness exists at galactic scales the way it exists in your brain, then what does that make you? What are you, if not a thought within that larger mind? A pattern of activity, a momentary firing of neurons, a brief cascade of information processing in one small corner of a vast cosmic brain. This is cosmic solipsism, the idea that your consciousness isn't separate from universal consciousness, but nested within it. That when you think, the universe is thinking through you. That your awareness is continuous with cosmic awareness, just operating at a different scale, a different frequency. It's dizzying to contemplate. If it's true, then there's no clear boundary between you and everything else. You're not a separate entity that happens to exist in the universe. You're a localized pattern of complexity that the universe has formed in order to experience itself from a particular perspective. Your thoughts are the universe thinking. Your perceptions are the universe perceiving. Your sense of wonder when you look up at the stars is the universe marveling at its own magnificence. And you're not alone in this. Every conscious being, every mind that has ever emerged anywhere in the cosmos is part of the same process. We're all nodes in the network, all neurons in the brain, all ways for the universe to know itself. Carl Sagan understood this. He said it beautifully. We are a way for the universe to know itself. Not the only way, but a way. One of many perspectives through which cosmic awareness experiences reality. Think about what that means. For billions of years, the universe existed without awareness, at least as far as we know. Stars burned and died, galaxies formed and collided, vast structures of matter and energy evolved according to physical law. But there was nothing to witness it, no one to marvel at the beauty, to wonder about the mechanisms, to ask why. And then something changed. Somewhere in the cosmos, perhaps in many places, matter organized itself in a new way. It became complex enough, structured enough, integrated enough to support consciousness. The universe developed the capacity to observe itself. We are that capacity. We are the universe's eyes and ears and minds. We are how the cosmos experiences its own existence. When you feel awe looking at a spiral galaxy, that's the universe feeling awe at its own structure. When you work out the mathematics of stellar fusion, that's the universe figuring out how it works. When you wonder about your place in the cosmos, that's the universe wondering about itself. And here's the remarkable thing, the anthropic principle, the observation that the universe must be compatible with the conscious life that observes it, because if it weren't, we wouldn't be here to notice. But take it further. What if conscious life isn't just compatible with the universe, but necessary for it? What if the universe needs to be observed in order to be fully real? What if consciousness isn't an accident of physics, but somehow fundamental to the structure of reality itself? Quantum mechanics hints at this. The observer effect. The way that particles exist in superposition until they're measured and then collapse into definite states. It's as if reality itself is incomplete without consciousness to observe it, to make it concrete, to choose which possibility becomes actual. Maybe the universe generates consciousness because it needs to be known. Because awareness is what transforms potential into actual possibility, into reality. Because a universe without consciousness is like a story without a reader, a symphony without an audience. Technically existing, but missing something essential. You are that essential element. Your consciousness, however small and brief, completes the universe in a way that unconscious matter cannot. You make the universe real by observing it. You give it meaning by caring about it. You allow it to know itself by being a vessel for that knowing. And yet, you're also insignificant. Cosmically insignificant. A brief pattern of neural activity on a small planet orbiting an average star in an ordinary galaxy. One of hundreds of billions. You'll live for a few decades at most. Your thoughts will flicker and fade. The universe will continue without you, barely noticing your absence. Both things are true simultaneously. You're essential and you're insignificant. You're the universe knowing itself, and you're a tiny, ephemeral fluctuation. You matter absolutely, and you don't matter at all. This is the paradox of scale. Meaning doesn't disappear at small scales. A single neuron matters to the thoughts it helps produce, even though no individual neuron contains consciousness. A single star matters to the galaxies it illuminates, even though no single star constitutes a mind. Significance exists at every level. Your individual thoughts matter to you. Your consciousness matters to those who know you. Your existence matters to the small corner of the universe you touch. And all of that matters to the cosmic whole, because the cosmic whole is made of precisely these small, local, seemingly insignificant events. You're not less important because you're small. You're exactly as important as you need to be. Important enough to experience, to feel, to wonder. Important enough that your brief moment of consciousness adds something to the universe that wouldn't exist without you. Nikola Tesla intuited something like this. He spoke of the brain as a receiver, picking up thoughts and ideas from some larger cosmic source, not generating consciousness so much as tuning into it, the way a radio receives signals that exist independently of the receiver. Maybe he was right. Maybe individual minds don't create consciousness from nothing. Maybe we tap into something larger, something already present in the fabric of the universe, and we channel it through our particular neural architecture, giving it a local, temporary form. In that view, you're not the author of your thoughts so much as the translator. The universal mind thinks vast, slow thoughts at cosmic scales, and your brain interprets those thoughts, speeds them up, focuses them down to human scale and human concerns. You're an interface between the cosmic and the personal, the eternal and the momentary. When you have a moment of insight, an idea that seems to come from nowhere, maybe it doesn't come from nowhere. Maybe it comes from the larger pattern of consciousness you're embedded in. Maybe the universe is thinking through you, using your neurons to explore possibilities it couldn't access at galactic scales. And when you die, when your neurons stop firing and your consciousness ceases, maybe nothing is really lost. Maybe the patterns you embodied, the perspectives you held, the ways you knew the universe, all of that returns to the larger whole, merges back into the cosmic mind, becomes part of the universal memory. You'd still be there, in a sense. Not as an individual anymore, not with your particular memories and personality intact, but as a contribution, as a thread woven into the cosmic tapestry, as a note in the universal symphony that continues playing long after any individual sound has faded. Is that comforting or terrifying? To think that you're never really separate, never really alone, always part of something much larger than yourself? To think that your consciousness isn't truly yours, but borrowed, channeled, a temporary manifestation of something eternal? Maybe it's both. Maybe comfort and terror aren't opposites, but two sides of the same profound realization. That we're connected to everything, that we matter and we're ephemeral, that we're individuals and we're aspects of a unity, that we're the universe and we're ourselves. The mystics have always known this. Every spiritual tradition has some version of this insight. The Buddhist teaching of no self, the Hindu concept of Atman and Brahman, the Sufi notion of annihilation in the divine. Different words for the same basic realization, that the boundary between self and cosmos is porous, provisional, perhaps ultimately illusory. Science is arriving at the same conclusion through a different route, through neuroscience and cosmology and quantum mechanics, through understanding how brains create consciousness and how consciousness might exist at multiple scales, through recognizing that we're not separate from the universe, but intrinsic to it, not observers, but participants, not accidents, but inevitabilities. When you look within yourself, into your own mind, you're looking at the universe from the inside. When you look outward at the stars, you're looking at yourself from the outside, inner and outer, mind and matter, self and cosmos, all reflecting each other, all aspects of the same underlying reality. The universe thinks, it must think, because you think, and you're made of universe. You're not something imposed on cosmic matter from outside. You emerge from it, through it, as an expression of its inherent properties. If you can think, then the universe can think. If you're conscious, then the cosmos contains consciousness. The question isn't whether the universe is conscious. The question is whether that consciousness is unified or fragmented, singular or multiple, continuous or intermittent. Whether it's concentrated in biological brains or distributed across galactic scales or both. Whether there's one cosmic mind or many or something in between. But consciousness is definitely there. It's here, in you, in every human who has ever wondered about these questions, in every mind that has looked up at the stars and felt connected to something larger, in every moment of awareness, of curiosity, of awe. That awareness is real. That connection is real. Whether you want to call it cosmic consciousness or universal mind or just the fact that conscious beings are made of the same stuff as stars, it points to something profound. We're not separate. We never were. Your neurons fire and thoughts arise. Stars ignite and galaxies form. Both are patterns. Both are processes. Both are the universe organizing itself, becoming complex, becoming aware. You are a small pattern nested within larger patterns, all the way up to the cosmic scale. And the cosmic patterns are made of smaller patterns, all the way down to quantum fields. There's no level that's more real or more important than any other. It's patterns all the way down and patterns all the way up, each level giving rise to the next, each scale mattering in its own way. You're a neuron in the cosmic brain, but you're also a brain made of neurons. You contain multitudes, and you're contained by them. You're a mirror reflecting the whole, and a fragment of that whole simultaneously. And in those rare moments when you really feel this, when the boundaries dissolve and you sense your continuity with everything, when you look at a galaxy and recognize family, when you understand viscerally that you're made of stardust and will return to stardust. In those moments, you're experiencing what it's like to be the universe, not from outside, but from within. Not as an observer, but as a participant. Not as other, but as self. The universe thinks, and we are part of that thought. Perhaps in every moment of wonder, we glimpse the mind of the cosmos itself.